Alright guys, we're back again. Now let's have a look at a Free State paper. What's up guys at Tabong, Velcom. What's up guys in Bloemfontein? How are you guys doing? Free State, we know they always get the best grades, and then 100% learners passing there. So let's see exactly how are they doing that, or what kind of questions are they writing on the prelim before they go to the national, where they really excel. Right. Okay, now let's have a look at 5.1. 5.1.1, it says that if tan theta is equal to 8 and is between 0 and 90, show the following. All right. So in this case, now they want us to show them this. All right. Good stuff. So now what we can do here is to have our diagram. It said is between 0 and 90, so it's basically on our first quadrant, and then we know that this is opposite and this is adjacent, so we're going to look for R here. We're going to go ahead and use our Pythagoras theorem to do that, and then we know that it's going to be x squared plus 8 squared here, square root, therefore R is going to be plus or minus 10. So, but we know that it's always positive, so our answer will just be 10. Great stuff. So now, with that said, now let's look at this one here. We're going to solve it. This is the right hand side, this is the left hand side. So now we're going to say we are looking at it from the left hand side, because already on the left hand side we can see that we've got a compound angle. Thank you very much if you said compound angle plus x. So therefore we're going to have a 10 there. What we need to do now is to expand this whole thing. Now let's have a look. It's going to be sine theta times cos x, and therefore it's a plus cos theta times sine x, all close in bracket. So this is 10. So we know what is sine 10 is going to be opposite over hypotenuse, which in this case is going to be 8 over 10 times by cos x plus this one here, which is cos theta, is going to be adjacent over hypotenuse, which is that, times sine x. All right, with that in mind, let's go ahead and close the bracket there, and therefore we need to multiply throughout by 10. So we're going to be left with cos x plus 6. When we multiply throughout by 10, guys, I'm multiplying throughout by 10 here, and then we're going to have sine x. Right. So therefore this is equal to the right hand side. Great stuff. Now that's it's out of the way. Please let me know what you guys think. Now let's move on to 5.1.2. 5.1.2 said hence solve this equation. You are solving for x there. Okay, great stuff. So now, because they had already said that tan sine theta plus x is equal to what? Saying is equal to 9, because what, this side we know that is already equals to this side. Okay, we know that they're equal. So now the only thing that we need to do here is to find out what is theta. Okay, so now guys, what we can do, we can go into our calculator and find out what is theta. So with the one that is given, okay, is either you use this one to find theta, or you can just find sine theta is equal to 8 over 10. The answer should be the same, guys. You're gonna go second function, 8 over 10, which gives us 53.30. right. With that in mind, then I can come and substitute theta there. Sine theta, which is 53.13 plus x, is equals to 9. Because I'm looking for x here, so I'm going to divide everything by 10. Divide everything by 10, cancel that 10 out, and then what else now? Okay, then I'm gonna go 5 3 1 plus this, and then I'm going to say remove the sign here by saying second function 0.9, which is going to give us 53.13 plus x, giving us a 64.160. Therefore, to solve for that, you're just gonna take 53 to the other side, 53.13, which gives us an x value of 11.03. Okay, 2 decimals. That's what I'm getting, guys. Please let me know what you guys think, or what are you guys getting in this question. Very interesting one. Now we see why at Free State they are doing the best. Okay, so but their questions are doable, so you can also use Free State paper to practice, guys, like you're doing now, tuning into this video. Let's move on to 5.2. okay, 5.2 says here, this is what is given to us in 5.2. right? So simple said, just simplify this. 90, I always said this one will always come, so we know that is going to change into sine x and it's going to be negative. Now this one here, when you take out a negative, you put it here. You are going to take out a negative there. This will be positive, and then this sign will be a negative. So basically, when you take out a negative here, you're going to be left with cos 1. And then here, this needs to be put negative, so that when you multiply throughout, it can be positive again. So therefore, 1 minus is going to give us a negative. Yes, and on this quadrant, cos is negative, so it's going to be negative, negative, which will make cos positive here. So it's going to be positive x. Therefore, multiply by, is it? It's going to be negative, guys. I'm sorry about that. It's going to be negative. Yes, and then here, we're going to have 360 plus. In this quadrant, tan is also positive all over. Added 240 is cos positive or negative. It's just going to be negative cos 60. How did I do that, guys? You can say, you can minus from that one. You can say 180 plus 60. So this is basically what I did, is 180 plus 60, which gives us this number here. That's how I simplified that one. And then 225, also here I said 180 plus 45. 180 plus 45 here, guys. Okay, so make sure that you don't get lost where tan is positive as well. Great stuff. So with that in mind, we can come here and simplify. Negative times negative is going to give us a positive cos, and then also sine there, then sine over cos here. I also changed that tan, and then here cos 60, it's a half, so it's going to be negative half there, and then tan is 45 is just going to be 1 cos, and that would cancel out. Then you are left with sine squared at the top, and then divided by a negative is going to give us negative 2. So this is what you are left with when you simplify. Right, moving right along. 5.3. 5.3 said prove this identity. Okay, so this one, guys, you can see even this side needs to be a little bit of simplifying, but okay, now let's tell the examiners that okay, we're gonna start on the left hand side. Okay, we have got 1 plus cos 2a all over cos 2a. All right, so simplify this. 1 plus this cos can be changed to cos squared a minus 1 all over this one can be changed to 2 cos squared a minus 1 as well. Okay, guys, and then when you simplify this one and that one would cancel out, so you're only going to be left with 2 cos squared a all over 2 cos squared a minus 1. Okay, so now let's look at the right hand side of this equation. So there is a tan, there is gonna be given tan 2a all over cos 2a. Okay, therefore multiply by cos a all over sine a. Right guys, what I did here, I did the reciprocal of this already, so it should give you this one here. You can double check my mathematics. Right, so at the top you're gonna have 2 cos a sine a. It's a double angle identity, that one guys, you can change it. And then therefore, what else can you do here? You can also change this into 2 cos squared a minus 1, and then yeah, there you go, cos a sine a as it is here. Therefore sine, this sine here should cancel out with the sine there. Therefore you're gonna be left with 2 cos squared a all over 2 cos squared a minus 1, as my phone rings guys. Okay, I'll get back to that one. Okay, so this is what you have then. Now therefore the left hand side should be equal to the right hand side. So the right hand side is equal to the left hand side. Okay, great stuff. So now let's move on to, do we have 5.4 or this is the last question? Okay, we do have 5.4, which is quite interesting. Let's move on to 5.4. 5.4 says here we are given here sine 32 is equals to t. Determine sine 16 in terms of t. All right, so now this is what you can do here. Let's come here and say, okay, sine 32, let's come here and have a look at our diagram guys. So we know that this will be over 1, which is our hypotenuse. This is opposite. Therefore you use Pythagoras theorem to find out that this one here will be 1 minus t squared. Guys, I'm gonna leave Pythagoras theorem to you guys. I think we've done it a lot here on this channel. Okay, with that in mind, so now when you come here guys, you'll have a look at 16. 16 looks like 2 times something else. So if you were to come here and say cos 2x can also be rewritten as 1 minus 2 sine squared x, can also be rewritten like this. All right, so therefore we can say this x here, x is equals to 16. Okay guys, don't make that mistake. Okay, x is equals to 16 because now they want us to find this one alone. So now we can put here cos 2 16, which takes us back to 32. We are happy with that one. So 1 minus 2 sine squared, remember now, sine squared what, 16 guys. Great stuff. Okay, so now with that in mind, so we're going to have what, cos here 32, then we're solving, we'll take 1 to the other side, 1 is equals to negative 2 sine. Okay, my battery is low guys. Right, now let's quickly do this one. So sine squared 16, hopefully this laptop won't die on me. Okay, so therefore divide everything by negative 2, this and that would cancel out. Therefore you're gonna be left with cos 32 minus 1 divided by negative 2. Then here you're gonna have sine 16 squared. Then you take the square root of both sides, square root that. Okay, so therefore you're gonna have sine 16 there, and then you're gonna have, okay, now let's substitute these ones now. Okay, this cos 32 is going to be adjacent over hypotenuse, right? Am I right? Yes, it's going to be adjacent over hypotenuse, which is square root of 1 minus the t squared over 1, which is just going to be like that. Okay, and then minus 1 there, and then all over negative 2. Okay, great stuff. So that's sine 16, guys. You would have solved it like this. Quite an interesting one indeed, guys, where you have to a little bit apply your mind and also apply the double angles there. I hope you guys get it. Right, let's move on to 5.5. 5.5 said you need to prove this identity, that it can be written like that. Okay, so let's go ahead and have a look at 5.5.1. It says here we need to prove this identity. We've got cos x plus y minus cos minus y. Okay, great stuff. So guys, this is just simple and straightforward. When you expand this using compound angle, this is what you should get. So I'm just gonna write it here the way it is straight away. Okay, it's gonna be cos x cos y minus sine x sine y negative. Okay, here I'm just gonna multiply throughout with a negative, guys. Please just bear with me. You guys can just double check my math. I'm just gonna work it out the way already as if you guys are following. All right, so with this is what we have now. We're gonna minus the cos. They will just minus each other out, and then negative and negative, we're gonna have negative 2 sine x sine y. Great, and it is equal to the right hand side thereof. Okay, so now 5.5.2. Okay, they said hence, otherwise we need to prove that it's equal to that. All right, so now with this on this side, this is what I would do. Okay, now from the left hand side, this is what you can do. You need to substitute them as they are, cos. Okay, then on the space of a, this is what I'm going to put, cos a plus b. Guys, you can expand if you want, but I think we've already done enough expansion from that one. Divide by 2, close. Okay, so negative cos is going to be a plus b all over 2 minus a minus b all over 2, close bracket. Okay, great stuff. So now with that, guys, you know that if you were to expand this from this equation here, guys, you know that if you expand it, you're going to be left with this. So now if you take that as what is left, you're going to say minus 2 of what is left. So it's going to be sine x. So in this case, this is our x here, this is our y. So x will just have to be a plus b all over 2. Guys, please let me know if you're getting this, because I'm little bit rushing here because my laptop is about to switch off. Minus b over 2. Right, I think it's simple, straightforward, guys. You just have to know what you're putting where, but please let me know what you guys think. But I think I've done justice to this question of Free State. The guys in Free State, drop a comment, let me know where you're watching us from. I am Gastin Mapala. Let me see you on the next one. We will be doing question 5 of another province.